Okay, so I'm going to begin by describing three important visual pathways that happen within our visual system. For visual perception, the dominant pathway is the one that goes from our retina to our thalamus in the middle of the brain, to primary visual cortex at the back of your head, and then on to the rest of the brain for further visual processing. For eye movements in particular, we have a pathway that goes from the retina to the superior colliculus in the middle of your brain, to the pulvinar nucleus of the thalamus, and then on to the extraocular muscles that control where you look around a scene. For pupillary reflexes, we have yet another pathway, and that's from the retina to the pretectum, down to the oculomotor nerves and back to the pupil to control how much light comes in. And I'll be describing all those in more detail. So here's the pathway that is most important for perception. So what we're looking at here is the brain from the bottom upwards. So you have the eyes, and at the back of the eyes you have the optic nerves, and like a cable, as it were, that's coming out of the back of the eye and taking that information to the brain. The cables from the two eyes cross over at the optic chiasm. So that's from the Greek letter chi, which is X. You can see it forms an X shape. The pathways after the optic chiasm are known as the optic tract. They then form a synapse, the first synapse after the retina, in the lateral geniculate nucleus of the thalamus. Thereafter there's another set of nerves that outputs sense axons from the LGN to the brain, and in particular primary visual cortex at the back of the head. And the nerve tracts that go from the LGN to primary visual cortex are called the optic radiation. So let's look in more detail at the optic chiasm, because I think this is a quite interesting crossover. So obviously we have two eyes, the left eye and the right eye. I'm going to mark the fovea, so you'll know that, of course, the central, most sensitive region of the retina, so the centre of our field of view. We also have the optic disc, and that's the blind spot where fibres leave the eye and we don't have any photoreceptors. Okay, so the optic nerve leaves the back of the eye, crosses over the optic chiasm, and then projects on from the thalamus through the optic radiation to primary visual cortex. But you'll notice that something quite interesting happens. For each optic nerve, like here's the left optic nerve, half the fibres stay on the same side of the head and half of them cross over at the chiasm. It's called a partial decussation. So why does that happen? Well, actually, Isaac Newton was the first person to figure this out. So we know Newton as a physicist and gravitation and so on, but he actually made, as part of his interest in optics, he made great contributions to ocular physiology. And he was the first one to describe the optic chiasm and understand what it did. He described it as kind of in reverse. He's describing it here as coming out from the brain to the eye. So a vast multitude of these slender pipes and nerve fibres which flow from the brain, the one half through the right side nerve till they come at the juncture, the optic chiasm, where they are each divided into two branches, one passing to the right side of the right eye, the other half shooting through the juncture and so passing to the right side of the left eye. So hopefully you can see that he's describing here, as he's describing it from the brain and then going out into the two eyes. So why have this complicated arrangement? Well, you're presumably very familiar with the principle that the right half of the brain controls the left side of the body. So if you have a stroke on your right motor cortex, it'll produce deficits on the left part of your body. So you might have thought, okay, that same principle would mean that images from the left eye would go to the right side of my brain and images from the right eye would go to the left side of the brain. But that isn't quite what happens, because it turns out that the appropriate division that the brain makes here isn't between the eyes, but between the visual hemifields. So if you like, you can divide your field of view up into two: the right hemifield, that everything from the midline to my right side, and the left, everything from the midline to the left. Now imagine an object in the right visual hemifield. Okay, so it's coming from a long way over on my right, and it is going to project onto the left side of each retina. Okay, and then you imagine objects that are getting progressively nearer and nearer to the midline. And let's say I've got my eyes looking at infinity, so the lines of sight are heading parallel out in front of me. And similarly, objects that are on the left visual hemifield project to the right side of both retinas. Now what the chiasm does, it ensures that all the information about objects in the left visual hemifield are collected together and delivered to the right half of the brain, to right primary visual cortex. And similarly, all the information about objects in the right visual hemifield is delivered to the left part of the brain.